All right, so last section of your notes. All right. So we're dealing with the areas of similar polygons. So if you have two polygons that are similar, for example, these two right here, KLMN and PQRS. So the ratio of their areas will equal to the square of the ratios of their corresponding side lengths. So for example, if we found the area for polygon PQRS, and that's our new, and we put it over our original polygon, so KLMN, their scale factor or their ratio should equal to any of the corresponding lengths, but we have to square those corresponding lengths in order to get the same scale factor. So let's just do an example together. So let's look at number 10. So they let us know that our two triangles right here, so PQT, okay, is similar to RST, right? And the area we know for sure for RST is going to be 75 meters squared, right? So they want us to find the area for PQT. All right, so when we set this up, okay, so we have our area for, right? Okay, so all we need to do now is just substitute our numbers, our numbers that we know for each of our area and our side length. So let's go ahead and do that. So the area for triangle RST is 75, and we don't know the area for PQR, but I'm just gonna leave it simple and just put A. Okay. Now RS, so RS is 10, and PQ is 14, so I'm just gonna square that whole thing. So you can actually say that 75 over our area for triangle PQT, okay? You can say this, when you have a square over a fraction, you can square the numerator and also the denominator. So for example, you can say this is 10 squared and 14 squared. So you just need to make sure you square both. So when we do that, okay, you get 75 over A, our area, is equal to 100, right? Because 10 squared is 100, and then 14 squared is 196. And then now we just do what we did before, just cross multiply. So when I cross multiply 75 and 196, I should get, it's going to be a little bit bigger number, so 14,700. Now when I multiply 100 and A, I should just get 100A, or you can say X, you can use any variable. So now it looks similar. All I gotta do is divide 100 by both sides to get the area by itself. So I should get 147, and we're dealing with area now, so I'm gonna have meters squared, okay, is equal to the area for triangle PQT. So this is going to be 147 meters squared. So now I'd like for you to try 11 and 12 on your own. Just a hint, it might be helpful to separate your polygons by itself, separate the two because I know they're together. So pause the video, try it on your own, and then come back with me to double check. Okay, so let's look at number 11. Okay, so if triangle GHJ is similar to KHM, okay, and we know for sure that from KH that's going to be 2 centimeters. And from K to G, that's 3 centimeters. And then we notice that this triangle right here So KHM, oops, sorry. We see that its area is going to be 6 centimeters squared. So now we're just trying to find the area of this big triangle right here, so GHJ. So it might be helpful to separate the two so you can kind of see what's going on, or you don't have to. So if I draw my little triangle right here, so you have K, H, M, and we know he is 6 centimeters squared for his area, and we know that KH is 2 centimeters. Okay, and if I were to draw my other triangle, okay, so from G to H, if we look, this gives me a total of 5. So 3 plus 2 gives me 5 centimeters. So from G to H, that's 5 centimeters. And we don't know his area, so his area is unknown. Okay, so I'm going to leave an A for area. Okay, so if we look, I can set this up as a ratio proportion. So I know the area for KH is 6 centimeters, so he's old, so I'm going to put him down here. And then I don't know GH, so I'm going to leave A. Okay. Now I know KH corresponds with GH. So GH is my new, so I'm going to put 5 right here. And then KH is 2. So the next step, because I'm dealing with area, I have to square this ratio right here. Okay. It's going to square both. Okay. So now I have A over 6 is equal to, and then 5 squared gives me 25. And then 2 squared gives me 4. Now I just cross multiply. Okay. So 4 times A just gives me 4A. 6 times 25, that will give me back, I believe, 150. Yep. Okay. And then I just need to divide 4 by both sides. So I have 4. Okay. And so now the area for GHJ is going to be 37.5 centimeters squared. So let's look at number 12. Okay. So if I'm determining that these two triangles are similar, then I just need to figure out if their ratio or their scale factor is the same. So let's go ahead and do that. So we see that GN, okay, so it doesn't matter in this case. They don't tell you who's new or old. It won't matter. You should get the same thing if they're similar. So I'm going to say JN is my old, and he corresponds with ML. So ML is 4, okay. So if I look, I should have 4 over 10, okay. And that is the same, if I simplify that, as 2/5. Okay. So I need to pick another side. So I dealt with 4 and I dealt with 10. So now I can look at maybe the other width of this triangle. So NM, and he corresponds. So MN, okay, if we look right here, MN corresponds with LK. So LK, right? If we look, we just substitute. So MN is 25 and LK is 10. Okay, so if I were to simplify that, okay, they both have a common factor of 5, so 10 divided by 5 gives me 2, and 5 divided by 5 gives me, or 25 divided by 5 gives me 5. So if I look right here, 2/5 and 2/5, I can see that the ratio of the corresponding side lengths are the same. So therefore, these two triangles are similar to one another. So this is a yes.